Hi everyone, welcome back to the GCSEMathsPro YouTube channel. In today's video, we're just going to be going through the November 2021 paper 2. This one is November 2021 paper 2, higher tier Edexcel paper. Yesterday we went through the November 2022 paper 3, so we'll just be working backwards chronologically basically. On Monday, we'll go through the paper 3 from this year. We're basically doing both papers 2 and 3 because obviously the topics do mix up between them. It's not very clear what is only paper 2 and what is only paper 3. So it's best to revise or practice both of the papers for your calculator paper 2 coming up. And then after that, you can just figure out kind of what's left on the syllabus for paper 3. So let's jump into it. Make sure you do have your scientific calculator, not just any calculator or your phone one. Make sure you have some form of scientific calculator, whichever one you're planning to use in the actual exam. How many have we done so far? Oh, I don't even know. Quite a few because we did all of the, well, I think we did most or if not all of the paper 1 non-calculator ones obviously before paper 1. So quite a few. Find it. I've got like a playlist on my channel which is for the lives or just a playlist for the exam papers, so you can always have a look at that. Past papers, there's 24 currently in the playlist, so I'm going to go with probably 24 papers we've done so far, so you can always go back and have a look at those. If it's one that I've already done, you can go back and watch it from there as well. So let's get into this. We've got inequalities first of all. Question 1a, write down the inequality shown on this number line. So yeah, you basically just write the number that the circle is on, whatever circle it is, you write that number. In this case, just one of them, isn't it? Now, is x either bigger than that or smaller? Is it greater than or less than? Because it's obviously pointing towards bigger numbers, x is greater than -1, but also we're not going to put equal to because it's not coloured in. So it's just like an empty circle, isn't it? So yeah, x is greater than -1. And then for part B, we need to, on the number line, draw or show the inequality that y is basically between -3 and 4. So we draw circles on those numbers. It doesn't matter what type of inequality it is, you always draw the circle on the numbers. And then, yeah, this one that does have the equal symbol, we're going to colour it in. We'll just fill it in. And then obviously just join them up with a straight line. Just grab my straight line. Oh, that's massive, but yeah, you get the gist. So on -3 and 4, one should be coloured in, one should be left blank, and then just join them up because it's obviously a range, it's not open-ended, there's no arrow this time. Am I doing live streams during half term? Yes, I will continue to do the live streams during half term. I'm trying to watch it back on my own, but it went a bit blurry. Hopefully it didn't go blurry for you guys. Yeah, I will be doing live streams during half term as well, which is next week, isn't it? Question 2, we've got find the highest common factor of 60 and 84. Now I know that they did technically ask you this in paper 1, so chances of them asking it again I guess is low, but we're just going to obviously do the whole paper anyway. Will there be ones the night before the exams? Yes. Yeah, it'll be Tuesdays, won't it? There should be some the night before as well. Whether that's, I think I might do kind of like a last minute revision session and then maybe also one last paper depending on what you think you would prefer. Last time for the paper 1, I think the night before I did a kind of last minute revision session of just a few topics that I thought were the most likely to come up. And then after that we did one last paper. So there were kind of 2 options of what you could join in with. So highest common factor. There's obviously different ways to do this. I like to just break it down into the product of prime factors. Now, you can do the factor tree, but obviously given that it is a calculator paper now, we can also use the calculator to give us the product of prime factors. So I like to type that in, just put 60, and then I don't know where it'll be on your calculator because you might have a different one to me, but I press shift and then where it says fact, if you can find that on yours. And then you see how it's literally just broken it down for me. So that one's 2 squared times 3 times 5. If it's just a product of prime factors question, you would have to kind of put some kind of working in the middle, if that makes sense. You can't just write the answer straight, because otherwise you won't get the 2 marks. But this one's obviously highest common factor, so that's fine. I would do the same obviously for the 84. Might as well save us some time. Fact, and then 2 squared times 3 times 7. Now you can obviously lay it out in the Venn diagrams. I normally do that, or if you're happy to just see which ones they have in common, you can do that as well. But I'll show you the full method. You just scribble circles. You don't have to do kind of nice circles, just scribble them out. Something like this. 60, 84. Now, because highest common factor is just where they overlap, so do you see how they both have a pair of 2s? So we've got a 2 and a 2. They both have a pair of 3s, and then technically the rest is, you don't really need to fill that out, but the rest is on the other sides. So the highest common factor is just this middle bit. So you don't necessarily have to draw the Venn diagrams. You might be able to see that just from the list of product of prime factors. But it's basically 2 times 2 times 3, which you should get 12. Obviously, if you did just list the factors of 60 and the factors of 84 and you got 12 as the highest one, then that's also fine. You've got a grade, you want to get a grade 8, I'd have to calculate it with the grade boundaries. Yeah, I'd have to calculate it with the grade boundaries. But I think I put them up on one of my other videos, the average grade boundaries. I don't know if you're doing Edexcel, I'm assuming you are, given that this is an Edexcel past paper. I did put them up on one of my other videos, the average grade boundaries, so you could use that to work it out if you wanted, to see the chances of still getting an 8. Because I don't know literally off the top of my head. Yeah, you're doing Edexcel. Yeah, one of my previous videos, which one was it? Was it the one, I think it was the one that was I posted on the day of the first exam. It's like a 5-minute video. I'm pretty sure I put a screenshot of the grade boundaries, the average ones for Edexcel. So if you go have a look at that, you can see the average grade boundaries, and if you just just calculate it, work out, take away the 60, what did you say you got for 45, take away the 45, see what you need to then get left to add up to a grade 8, if that makes sense. So find the lowest common multiple of 24 and 40. Again, you could list out the times tables of 24 and 40 if you want, or you can do the product of prime factor method. It's up to you. So 24 is 2 cubed times 3, and then 40 fact button 2 cubed times 5. So the lowest common multiple is all of them multiplied together. Not literally all of these, but as in, let's say if you were to, again, do your Venn diagrams, you fill it out. 24, 40. What do they have in common? They have obviously 2 cubed in common, so I'll just put one lot of that 2 cubed there. 3 and a 5. You multiply all of this together. So not the 2 cubed twice, just once, if that makes sense. Whatever's in common, you just multiply it once. And then whatever's left, you multiply by that. So that's obviously, I mean, you can put it in your calculator, but 8 times 5 is 40, times 3 is 120. However you wanted to work it out, as long as you get 120, should be fine. There we go. So 4 marks. But again, they have kind of mentioned this. This was one of the questions, wasn't it? The highest common factor in the paper 1. So I don't know if they'll ask you this again. So question 3, we've got Sam drives his car on a journey. Here is the travel graph for the first 15 minutes. You can see it's obviously time of day, but you can see that that's like 10, 15 and so on. Work out Sam's speed in kilometers per hour for the first 15 minutes. So effectively it's basically just, I guess, like the gradient, but I mean, we're starting from 0, 0, so it doesn't really make a lot of difference, does it? So the distance, so we know that it's distance divided by time, but because they want it in kilometers per hour and they've said 15 minutes, you have to consider that, right? So it is, he's gone 20 kilometers, isn't he? Technically it's 20 minus 0, but you know, it makes 20, doesn't it? And then the time is obviously from 10 to 10:15, which is 15 minutes, but as a decimal, that would be, or you could put it as a fraction if you want, but that would be 0.25 of an hour, like a quarter of an hour, isn't it? And again, technically minus 0 just to make it the gradient, but that doesn't really change much, does it, in this particular case? So it's basically 20 divided by a quarter, isn't it? Again, some of this you might be able to just work out yourself without a calculator anyway, but it's up to you. Which obviously multiplies it by 4, so 80. So just make sure that you do convert the minutes into hours. Is it possible to get 80? I mean, it's not impossible, but I feel like unlikely, really. Even if you make small mistakes, isn't it? But I don't know who's aiming to get 80. Because the grade boundaries aren't as high as 100% necessarily. I guess it depends how paper 1 went, doesn't it? So at 10:15, Sam stops for 10 minutes, then drives for 20 minutes at a speed of 75 kilometers per hour. On the grid, complete the travel graph for Sam's journey. So obviously you're going to draw the 10 minutes, but let's just work out this bit first before we start drawing it. So we will now want to work out the distance, don't we? Because we've got the time, we've got the speed. So we want to work out the distance. Speed is distance over time. We're working out the distance. You see how we'd have to multiply them. But again, because the speed is in hours or kilometers per hour, you can't just times it by the 20. You'd have to make that into hours. So technically 20 is just 1/3 of an hour, isn't it? Or if you're not sure how to convert it, you just divide the minutes by 60 and that will give you how many hours that is as a decimal. Obviously that's 1/3. And I would leave it as a third because obviously that's a recurring decimal, isn't it? So 1/3 of 75 is 25. So he's travelled 25 kilometers in those 20 minutes. So now let's look at our graph again. If I scroll back up. So the first thing is that after 10:15, he stops for 10 minutes. So he's not going anywhere, but the time is still running, isn't it? So get my line. I'm just going to draw a line from here. Just be careful because this is 10:15. So we want to go to 10:25. So we're not traveling anywhere, so it's going to be a flat line, isn't it? The distance hasn't changed. Yeah, so it's stationary. And then we said 25 kilometers, so it's going to go from 20 up to 45, but that took 20 minutes, didn't it? So then across, that's 5 minutes, 10, 15, 20 minutes, so here effectively, isn't it? And you just do that as a straight line as well. So it should look something like that. It should be touching here, 10:45, and then 45 kilometers. Okay. Yeah. Yeah, so in the live streams, because we go through the paper, obviously if it's got the 6 markers or the really hard ones at the end, then we will go through those towards the end of the paper. We're just going through obviously in order, but we will get to those ones as well. So question 4, I think something like this also came up in paper 1 anyway, so whether they'll ask it again, I don't know, but we'll just see. So obviously now that we have got a calculator, let me try and get my calculator back. There we go. I would probably do this again using the calculator. It might work differently for yours. Again, you just have to figure out kind of how to set it up. But we've got here that we need to complete the table of values for y is x squared minus 2x plus 2. Now, obviously, you can work it out by subbing in -1, subbing in 1, subbing in 2, subbing in 4. But do you see how the clue is that we don't have any working out space? I know there's space here, but you see where the marks are? That's technically where the question ends. So, like, there isn't really technically any working out space. So they've kind of hinted that they don't want us to necessarily physically work it out, each one individually. So I would probably just set it up into the calculator. So the way that I do it on this one, but you can figure out on yours, is I press mode. Yours might be called menu, something like this. It gives you a list. Just try and find one that says table. Mine's number 7. I know on one of my other calculators it was number 3, so just double check. I press 7. You should get something like f of x. You might also see g of x as well. You might have 2 of them. Again, just depends on the calculator. F of x is just like a substitute for y. It means the same thing. So at this point, I'm going to type in the x squared minus 2x plus 2. So you might have to use alpha to get x. You see I've got x here. Squared minus 2 just as normal, and then x again plus 2. So just type in whatever. This works for any type of graph, not just a quadratic. See there I've got g of x. That's if you've got a second graph, but I don't have a second graph, so I'm just going to ignore that. The start is where you're starting, so you can put -2 or -1. -2, you technically already know what 10 is, so you could put -1 if you wanted, but -2, let's just go with the start of the table. So I'm just kind of writing it over the top of what they've put. They've suggested the end is 5. In this case, we only need to go up to 4, isn't it? And then the step is the difference between. So you see here, normally it is just 1. So I would just leave it as 1. Now it does give you, often does give you like a vertical table. So you just have to kind of correlate it to your horizontal table, right? So the x column is obviously the x values, -2, -1, 0, 1, 2, 3, 4. And then the f of x, as I said, represents y, which you can see we've got -2, 10, which is the one they've already written. And then for -1, it's 5. And then we've obviously got the 0, 2. So I'll just scroll down. The next one, 1, 1. So I write 1 here. Then scroll down again, 2, 2. You can probably guess what the last one is, but anyway. We've obviously got 3, 5 already. And the last one, 4, 10. So 10. Now, you can do that. What you can do is also, there's normally quadratic graphs are always symmetrical. Do you see how in this case the line of symmetry is at 1? Do you see how it goes 2, 5, 10, 2, 5, 10? So you can almost figure out the coordinates up until the point where it's become symmetrical, and then you can just copy them if you also want. But yeah, this is I think if you've got a calculator, you might as well do it that way. Also, because sometimes when you substitute it in, the negative doesn't square properly and then you get the wrong number. But yeah, I'm actually, tomorrow morning, I'm uploading a calculator tricks video. It's uploading, I think, at 8 AM. Obviously, you can watch it later on. But yeah, so this is obviously one of the tricks that I show you. Yeah, I didn't know this when I did GCSE, and actually it probably would have saved me a lot of time. So we've got that. Obviously now, we just need to plot those values. So that's pretty easy. So you'll obviously be able to see the whole page when you've got it in front of you, but -2, 10, -1, 5. Just be careful of any scale if it's, you know, halfway between and so on. 0, 2, 1, 1, and then it goes back up again, 2. And you should, obviously, because it's a quadratic, hopefully you'd know that this is the shape that it should create, so you'll kind of know if any of your coordinates are incorrect once you draw it, because obviously if it doesn't create a U shape, then you know something's gone wrong. Obviously then join it up. I would obviously recommend doing this with your pencil so that if it goes wrong you can rub it out. Hopefully you'll do a much better job than I'm doing. Yours will be a lot more, won't be as wobbly as mine is, but anyway, you get the gist. It's obviously, oh, that one's really bad. It's obviously meant to be kind of like a U shape, like that. If it's a negative quadratic, it'll always go upside down. It'd be kind of like an N shape. Anyway, the thing that I thought was interesting about this one was part C. So use your graph to find estimates for the solutions of the equation x squared minus 2x plus 2, which is our quadratic, wasn't it? That was the same one as our quadratic, this bit, equals 4. So what I want you to kind of see there, again, there's no working out space. There's just enough space to put your answer. And it says use your graph, so that's the other hint. But do you see how that's the same as our graph? We're not going to draw a different graph. So what that means is on the other side, originally was y. Now, I know they've swapped it left and right, but that doesn't really make any difference. Do you see how now it's 4? So what that's telling me is when y is 4. So it's almost like simultaneous equations. Obviously, just one of the equations is y is 4. The other one is the x squared minus 2x plus 2. So we're going to draw a line where y is 4. Normally that one equals to 0, but sometimes they throw in a different number. So you're not meant to rearrange it or anything. I know naturally you might want to rearrange it, but as I said, there's no working out space. So you're just going to draw a line at y is 4. Or whatever number they might have given you if it was different to obviously 4. There, and then we're going to see where it crosses. So we're only going to write down solutions for x because we already know that y is 4, like that's already implied. So you're just going to see where it crosses here and obviously here. So roughly, kind of to 1 decimal place, or you could do 2 decimal places if you want, but they'll give a small range because obviously you can see my curve is not very well done. Let's see, what's that? Minus, kind of like minus 7.5, that one, I think. Well, as in minus 0.75, sorry, that one. And then the other one, 2.8, I guess, 2.8. That's what I would put. There is a slight range. I'll tell you what the range is in a sec, so you know if you've got your answer within that range. So that's for x. We don't need to write down y, because first of all, we know it's 4, but also, do you see how in the equation there was no y? So you don't need to write down the y in this particular case, just the x coordinates. So the range of possible values, let me just grab my notes. Yes, you could have got anything between negative 0.65 to negative 0.8. So as long as you've got anything between that for one of them. And then the other one is kind of like the same decimals. So anything from 2.65 So 2.8. So you can see I was just about on the edge of that. But that's because mine wasn't drawn very well. Obviously yours will be drawn a lot more accurately than mine. So there you go. Yeah, I would agree. The November papers for some reason feel different, don't they? They feel a little bit more difficult. Maybe they just word things differently. I don't know what it is. It just feels different, doesn't it? So yeah, you could always try the November papers specifically if you wanted. But yeah, as long as you've got anything between these two values for both, then yeah, 2 marks. Okay, question 5. So we've got here is a right-angled triangle. You can see we've been given 2 sides and no angle, so you probably already know where we're going with this. The shaded shape below is made from 2 of these triangles, so the exact same 2 stuck together. Work out the perimeter of the shaded shape. So obviously, you've got the 8, you've got the other 8, you've got the 10, that's fine. But we've got 2 other sides that we need. We need the hypotenuse and then this little bit here. Don't forget about the small bit as well. But it's basically just Pythagoras, isn't it? Exactly. So I'm going to do Pythagoras of this top one. So 8 squared plus 10 squared. And then we square root it, don't we, basically? So obviously you would want to put that in the calculator because it isn't. Oh, just something to mention about this. Obviously, to get out of this, again, it will be on my calculator tricks video, but you just press the same, like, so do you see how I started with mode? Just go back to whatever number 1 is and it will kind of get rid of the table function for you. So just so you know how to get out of it again. Just do that. So 8 squared plus 10 squared. Now, because it's a decimal, if you see this is loads of decimals, I'm probably just going to leave it as 2 root 41 until the end, and then I'll round it at the end, but that's just my preference. So that side is 2 root 41, this side here, which on here is obviously this side here. Now, the only thing we're then missing is what is this small piece here? This bit here. And basically, it's obviously the same hypotenuse, isn't it? It's the 2 root 41, but if you take away this base side, which was the 10, so that bit there is 2 root 41 minus 10. Now we've got all of our sides, so we can just add them all together. So 2 root 41, I'll just take that as my answer, plus 8, plus the other 8, plus the 10, plus, I'm just going to put answer, but 2 root 41 effectively, minus the other 10. You could obviously cancel out both of those 10s if you wanted, but then I get this. Now, because this is now my final answer, I am going to look at the decimal, and it does say to 3 significant figures. So 41.6, that would round to, wouldn't it? Millimeters. So yeah, just don't forget this small bit here. I think it's fine to do the Pythagoras, but don't forget this kind of small side here that you can't quite see. That's the only thing, isn't it? So that was actually 4 marks, which I think is quite nice for 4 marks. Question 6, obviously now we've got some basic trig, which I don't think came up in paper 1, did it? So as far as I'm aware, I don't think it came up. So we might be looking at getting something like this in your actual exam for paper 2 or paper 3. So ABC is a right angled triangle. Work out the length of BC, so this base one here, obviously to 1 decimal place. So this is obviously now trig, isn't it? Because we've got an angle and a side, and when you've got those mixed together, it's obviously trig. So we've got here the opposite that I want, and then the one that I already know is the adjacent. So I just label the 2 of them, because then it tells me out of SOHCAHTOA which one to use, obviously tan. I'm looking for the opposite, so cross that out. So my actual calculation is tan 56, obviously the angle always goes with the sin or the cos or the tan, times 12. So get rid of all that, tan 56 times 12, not 11, 12. There we go. And now because this is my final answer, I will just straight away round it. So it says 1 decimal place, that's obviously 17.8. Yeah, also the thing with sine rule, right, is they won't ask you cosine or sine rule in question number 6. So just be aware of, like, I mean, also it's obviously a right angle triangle, but the fact that they will always put sine or cosine rule kind of the second half, if not towards the end. So if you're getting question 6 and it's only 2 marks, very unlikely to be sine or cosine rule this soon into the paper as well. So that's something else you can think of when you're trying to figure out what to do. Just think, how far into the paper am I? What makes sense for only being question 6, for example. So PQR is a right angle triangle again. So we've got another one again, but this time we need to work out the size of angle marked X. So we've got 2 sides, we want the angle. Still trig. If I label my sides, I've got the hypotenuse now, and I've still got the adjacent. So that's cos, but I'm finding the angle. So cos of the angle x is adjacent over hypotenuse, but because I'm finding the angle, I'm obviously going to do cos inverse. Whenever we find an angle with any form of trig, you always do the inverse. So shift cos, and then I'll just put straight in 15 over 18. Oh, my number keyboard isn't working today. 15 over 18, there we go. And then you can see that makes sense for an angle. So again, 1 decimal place, 33.6. 33.6. Yeah. So that was quite nice actually, because you had basically 2 of the same question. If you knew how to do one of them, you probably did know how to do the other as well. Okay, question 7, density. I feel like density comes up quite a lot in the calculator papers, obviously because of the decimals. So liquid A has a density of 1.8 grams per centimetre cubed. Liquid B has a density of 1.2 grams per centimetre cubed. So we've got the density of both. They've then said that 80 centimetres cubed of liquid A is mixed with 40 centimetres cubed of liquid B to obviously then make 120 centimetres cubed of liquid C. Work out the density of liquid C. So this is a formula you need to know. They won't give it to you. Density is mass over volume. I like to just use the formula triangle personally. Mass is the one that goes at the top. Now, because we're trying to work out the density of C, we would need the total mass of C and the total volume of C. Now, we currently do have the volume of C. The thing we don't have is the mass. So what I need to do is first of all work out the mass of A, the mass of B, and then add them. So that's what I'm going to do. To work out the mass, obviously I'm going to multiply. So mass for A is 1.8 multiplied by 80. Again, I'm just going to put that in my calculator. 1.8 times 80 is 144, and that's obviously in grams. And then the mass of B, just the same thing, 1.2 times 40, which I think gives you 48. Probably work out some of that yourself. And then obviously, therefore, the total mass of C is just those 2 added together. So take my answer, add 48, 192. So now I can actually work out the density of C, because I've got the mass of C, I've got the volume of C. This is the volume of C, isn't it? So the density of C is, well, if you kind of look back there, it was mass over volume, wasn't it? So 192 over 120. So divide that by 120. And then as a decimal, 1.6. And it's quite a nice number, 1.6. I feel like that gives you a bit of kind of slight confirmation that you're probably right, because it's not a horrible number. It's quite a nice number, isn't it? So you can kind of go, yeah, I'm probably right. So yeah, that's what we need to do. Just keep that formula triangle in mind and rearrange it as needed. Question 8. So the group's frequency table gives information about the time in minutes taken by 50 people to solve a puzzle. So that's just your normal frequency table. Brian was asked to draw a cumulative frequency table for this information, and then this is the table that Brian drew. Now, you didn't get cumulative frequency in paper 1, so I feel like, at least in my opinion, I think there's like a 99% chance it will come up in paper 2 or paper 3. This is obviously just a smaller kind of question. So we need to write down one thing that is wrong with this cumulative frequency table. The first thing I did was just check that they all added up correctly, because you're meant to just add them every time, aren't you? And it does, it all adds up correctly. The other thing is then, therefore, the other column. The problem is, I can circle it, this. That's the problem. I guess not the first one, but the rest of them are the problem. When you have a cumulative frequency table, because you're including more and more rows, it's always starting from 0, isn't it? Every time it starts from 0. So the problem is this. So I would say probably inequalities, I think, or the range, or something like, what did I write? I think I wrote, I can show you the examples, and the mark scheme is obviously multiple examples. I wrote the inequalities must start from 0, or like all of them must start from 0. Inequalities must all start from 0. That's just how a cumulative frequency table works, isn't it? They always start from 0. So that's the problem, not the numbers, but the actual inequalities. Now, if I just check the mark scheme, just to give you some other examples, because obviously worded ones, you could write something slightly different. So their examples are kind of like the main answer was just error in inequalities is what they said. But the acceptable examples is if you give at least one correct inequality. So for example, you could say that 10, well, as in t is between 10 and 20, should be 0 to 20, for example. So you could just correct one of them. You can say that all inequalities should start from 0, which is what I was saying. You could just say should start with 0. They would still allow that, even though you've not referred to what you were actually talking about. You can't just say that something is wrong. You have to obviously say what is wrong. That's the thing. So yeah, that one's okay. Question 9, we've got box plots. Again, something that might come up in the next papers because you haven't had box plots yet. We've got the box plot shows information about the length of time in minutes some people waited to see a doctor at a hospital on Monday. So we've got here the whole box plot, work out the interquartile range of the information in the box plot. So hopefully you know that the interquartile range is basically this whole box here, isn't it? So that's the lower quartile mark, and then this one is the upper. So then the interquartile range is just those two subtracted. Now, the only bit that's hard about this, I think, is the scale. So just be really careful every time you've got a graph, every time you have some kind of box plot, the scale. Because this here, that's 160 to 200, isn't it? So this is 180, this middle point here, and then you've got to figure it out. So I think each square represents 4 minutes. So that would be 188. So just be really careful of the scale. And then this one here, again, if each square is 4, you've got 44, 48, and then you've got half a square. So that's 50, isn't it? The lower quartile. 50. So obviously subtract them at that point. That's quite easy, isn't it? 138 should be your answer. And they don't give you any other options because obviously their box plot is exact. You can't get, there's no like range of answers. That is just the exact answer you should put. So Becky says 50% of the people waited for at least 2 hours. Is Becky correct? And obviously you have to say why. So I think the main reason is this line here. Oh, if I could line it up. This one here is the median. And the median is 50%, isn't it? So what that's saying is, from this mark here, there's technically 50% of people that waited less time than is written here, and 50% of people waited more time. So, because that mark happens to be 120 minutes, which is 2 hours, yeah, 50% of people did wait for more than 2 hours, because that's this side here, isn't it? That represents 50% of people, and it starts at 2 hours onwards. So that's what I would say. I would say yes, because the median is at 2 hours, or the median's at 120 minutes, something like that. Yes, median is 2 hours. And that just kind of implies, 50%. So that's one of the examples. You could say, yes, since 50% is at the 2 hour mark. So instead of saying the median, you could say 50% is at that 2 hour mark. You could say yes, because the middle is at 2 hours as well. You could say that. Obviously, you'll get it wrong if you say no in any format. If you just say the median is at the 2 hour mark and don't say yes, you have to say yes, if that makes sense as well. You don't just put the reason, put yes or no as well. Yeah, so that's basically that one. Now I think there is also part C. Yeah, so the table gives information about the length of time in minutes some people waited to see a doctor at the same hospital on Tuesday. So remember, the box plot on the previous page was Monday. This is now Tuesday. They've given us the same information that you would see on a box plot anyway. So Becky was asked to compare the distribution of the lengths of times people waited on Monday with the distribution of the lengths of times people waited on Tuesday. And she wrote, people had to wait longer on Monday than on Tuesday. Give one reason why Becky may be wrong. I was just comparing those figures. So for example, the median here, I think that's the most obvious one, is 100 minutes, which is less than 120 minutes, isn't it? And the median is kind of like an average mark, isn't it? So I just went with that. I said, why might she be wrong? Because the median on Tuesday is lower. That's what I said. Is lower than Monday. So if the average time waited is lower, yeah, or you could say the median is larger on Monday. That's, yeah, exactly the same thing. If the average time waited is less, then you could, because we're just saying why she may be wrong. It's not, 100% guaranteed, but You've said that. The other thing you could have said was if you compared the upper quartiles, they'll be happy with that, because they've said the upper quartile is lower on Tuesday as well. Or if you said it's higher on Monday, you could say there may just have been one person waiting for the 210 minutes. So you see the longest time, 210. I know that's longer than the longest time for Monday. However, that could just represent one person, couldn't it? It might not represent people in general. They've also said they'll accept, we don't know how many people were waiting for each time, so that's kind of a vague answer. But I think the median one is probably the most obvious. So question 10, obviously compound interest, again, something that I think will definitely come up at some point in the calculator papers. So Louise invests X pounds in better investments for 3 years, this one here. Sadiq invests X pounds in County Bank for 3 years over here. At the end of 3 years, the value of Louise's investment is £344,605. Work out the value of Sadiq's investment at the end of 3 years. So for Louise, we kind of need to work backwards, and then for Sadiq, we then just work it out as normal, because we don't know what the initial investment was. So I would set up my compound interest formula for Louise. So she invested X pounds, so just put X there. And then it was 2.5% every year for 3 years. So that'd be 1.025 to the power of 3. You can obviously type it differently than I have. If you use the formula, you can put like 1 plus 2.5 over 100, something like that. That's also fine, as long as it's kind of effectively the same thing. But then that equals the answer they gave us, isn't it? So do you see how I've got a very simple kind of equation here that I can now just reverse? Obviously, I'm going to use my calculator. I just need to divide by the 1.025 to the power of 3, don't I? So 344,605 divided by the 1.025, and then obviously cubed to the power of 3. And then that will give me X. Now, because I've got quite a nice number, it's kind of reassuring me that I'm probably on the right lines, aren't I? So we've got 320,000. So X was originally 320,000. So that's half of it. So we worked out the initial investment. Now, because they both invested X, they both invested 320,000, didn't they? So Sadiq's initial amount is the same. So now I'm going to look at County Bank. 320,000 multiplied by 1 point, and it's 2%, so 0.2. But that's only for 2 years, so squared. Now you can work this out and then work out the second one separately, but I just put it all in one. Times it by then 1.035. Now that was only for technically 1 more year. So it is to the power of 1, but obviously that makes no difference, does it? So that's what I'm going to put into my calculator. As I said, you can do it in split kind of steps if you want. I'm just going to type it all in at once. So I've got my answer there, which was the 320,000. 1.02 squared times 1.035, just to the power of 1, which is the same. Then I've got this, £344,580.48. That's the answer. What was it? 580. 48. That's your final answer. So as long as you got to that at the end, if you did it slightly differently to me, that's fine. If we got the same answer, then obviously you must have done it correctly anyway. So that's what I'd probably just leave the 48 because it is 2 decimal places anyway. I'm not sure if they mind if you round it. Let's check. They have given this as the official answer, but they've said as long as you write something between... Oh, they've given quite a big range actually. Okay, so I'll show you the range. As long as you've got something between this and 344,581, you might have rounded it to 581. As long as you've got something between these two values, they'll give you the answer, but this is technically the actual, like, exact answer, if that makes sense. So yeah, nice compound interest one there. Question 11, straight line graphs. So here is a sketch of the line L. The points P, -60, and Q03 are points on the line L, as you can obviously see. The point R is such that PQR is obviously a straight line, and PQ to QR is 2 to 1, so that's kind of the scale of the, the distance. Find the coordinates of R. If you state the number in pounds, do you always have to include pennies? No, but I just like to because I didn't really see the point in rounding the previous one just because it was already 2 decimal places and technically money is acceptable in 2 decimal places, isn't it? But as I said, they do give you that range. So if you'd have rounded it, let's say you rounded it either to down to 80 or you rounded it up to 81, they would have accepted that, yeah. I don't think they're that fussy about the rounding unless they specify how to round it, but because they didn't specify in that question, I don't think they're really that bothered. As long as you've obviously got something in the same ballpark. So yeah, we want to share out this ratio effectively, but we've got the side that is 2. Now I would, because it's diagonal, what I would do is I would just do x and y separately, if that makes sense, so horizontally and vertically. So the distance, and this one's quite tricky because there's zeros here and there and everywhere. Try and make sure you don't get the x and y coordinates mixed up, because I definitely struggle with that. So across, it's a distance of 6, isn't it? And then up, it's a distance of 3. Now that's on the side of 2, isn't it? So what I would do for each of those individually, 6 divided by the 2 to give me like 1 part of the ratio, and then times it by 3. Or you can just times it by 3 over 2. Same thing, isn't it? So that should give you 9 for the x. Now that's the distance though, so just be careful. Is that the actual coordinate or just the distance? So that's starting from Q, isn't it? Q up to R. Now in terms of the x, Q does start at 0. So technically 0 plus 9 is just 9, isn't it? So that's fine. That is the x coordinate. However, just be careful with the other one. So we've got 3 over 2 times by 3 as well, which I think gives you 9 over 2, or you could write it as 4.5. However, that's not the actual coordinate because you see how vertically, this is for x, isn't it? And this is for y. You see how vertically we're starting at 3 and then we're going up by 4.5? So like this is a distance of 9, 4.5. Now the 9 was starting at 0, so that's fine, but the 4.5 starts at 3, so that would be, you'd have to add on the 3. So you'd get 7. Right, I think it just cut out for a second, guys. Hopefully it's come back. Looks like my signal's really bad for some reason. Yeah, let me know in the chat if it's carrying on, but hopefully it's reconnected itself. So yeah, you should get 9 and 7.5. Okay, 9 and 7.5 as your actual coordinates. So part B, it then says find an equation of the line that is perpendicular to L and passes through Q. So just a really nice perpendicular line question. So we're passing through Q, so I'll just show you that. Q is obviously the coordinates 0, 3. So what we need to do is first of all find out the gradient. Now it's perpendicular, so what I'm going to do is find the gradient of the line, and then we can just do the negative reciprocal because we don't have enough information or coordinates for the perpendicular line, do we? We've only got one set, which is Q. So I'm going to do the gradient of line L. Yeah, exactly, negative reciprocal, which I'm just going to choose P and Q. You could obviously use R if you wanted, but I'm just going to choose P and Q. So on the Y, we've got 3 minus 0, and on the X, we've got 0 minus 6, or if you put it the other way around, that's fine as well, which is 3 over 6, which is obviously a half. So then the gradient, I'm just going to put P for perpendicular, is obviously, as you said, the negative reciprocal, which is minus 2. And then, well, actually, yeah, you can sub in the coordinates, but you don't even need to because you see how Q is on the y-axis, literally. So I wouldn't even bother subbing them in because it is just, the y-intercept is just 3, isn't it, for that line as well. So, but you can sub in the coordinates of Q, that's fine, you'll still get the same answer, but technically, if you look at them like more closely, in this particular example, yeah, you don't need to. So yeah, as long as you get y is minus 2x plus 3, then yeah, that's your answer. Question 12, expand and simplify. We've obviously got triple brackets. This, again, is kind of a calculator one, mostly from what I've seen. So this may or may not come up at some point. So normally I just multiply the first two, expand the first two, and then bring the third one at the end. You can technically do whichever order you want. So if you want to mix up the order, you can. But I just like to stick to the first two. So just be careful though, because this second bracket is a 3x. So when you multiply it, you get 3x squared plus 2x minus 6x. So again, just be careful of that 3x there. No, minus 4. Then I would obviously simplify that before I then multiply the third bracket. Minus 4x minus 4, 2x plus 3. And then you might expand it the other way around. I like to expand it this way around, so I'll show you with kind of drawing it. I'll do 3x squared times the 2x, that's 6x cubed. Then I'll do the same 3x squared by the other one, the other number in that bracket. So plus 9x squared. Then I move on to the next one, so the 4x. That's how I tend to do it. Some people like to start from the 2-part bracket and multiply backwards, but it's up to you. That's minus 8x. And then minus 12. X squared, that one. Minus 12x, and then need a third colour. Minus 8x, and then finally, so you should have 6 numbers. Obviously, when it's double brackets, you only have 4 numbers. When it's triple, you get 6 numbers. And then we're going to simplify this. The reason why that I do this in this order is because you see how now my like terms are right next to each other. So I just find it easier, but it doesn't really matter. It's not like that important at all. 6x cubed plus x squared minus 20x minus 12 is what you should get. 4 terms once you've simplified it. Okay. Question 13. So in a school there are 16 students, 16 teachers even, 220 students. Of the students, 120 are girls and 100 are boys. So one teacher, one girl and one boy are going to be chosen to represent the school. Work out the number of different ways there are to choose one teacher, one girl and one boy. This is, I call it product rule for counting. I know some people call it combinations. So whatever you call it, it's that topic. So in this case, we're just going to multiply them straight together. I mean, it's literally only 2 marks, right? So 16 teachers to choose from. Then I've got 120 girls that I could choose from. And then I've got 100 boys that I could choose from. So you're literally just going to multiply those together. Okay. It is a massive number, but then that's because there's so many students, isn't there? So 192,000. So obviously you get 1 mark for your working there, just writing that down, 1 mark for the answer. Question 14, circle theorems. Again, I think this is a topic you haven't had yet, so I would imagine they're definitely going to ask that at some point. So A, B, C, and D are obviously 4 points on a circle. SBT is a tangent to the circle, and then they've obviously labelled this angle 20. They've then told us that the size of angle BAD, so this one here, to the size of angle BCD, this one here, is 3 to 1. So those 2 angles. Find the size of angle SBA, which is all of this. So immediately I was just looking at these 2, and those are opposite angles. If you ignore this line down the middle, just ignore BD, that's a cyclic quadrilateral, isn't it? And those are opposite angles, the A and the C. So that's how I know that I could share out that ratio, because obviously opposite angles in a cyclic quadrilateral should add up to 180. So that's why I was just thinking, oh, I might as well do that. So divide that by 4, you get 45. Yeah, exactly, cyclic quadrilateral. And then you can work out, obviously, well, this side is therefore 45, isn't it? The other side is 3 times that. BAD is 3 times 45. Now this one they have asked for reasons. Sometimes they don't, sometimes they do. So I would write down, obviously, opposite angles in a cyclic quadrilateral. add up, or 180, or some version of 180. Oh, put equals 180, something like that. That's one of our reasons. So then what was that one? That was 135, I think. Yeah, then what I was thinking is, because you've got a tangent, and then do you see how technically you've got two triangles here, but you could use either of them. As long as you've got this kind of triangle that's stuck to the tangent, but also just make sure all three corners are on the circumference, then yeah, you've got alternate segment rule, or alternate segment theorem, whatever you want to call it. So yeah, I was going to use that. What I was going to do is get a different color. Is I know because of that this angle is the same as this one. Yeah, or you could do, well, I guess you could directly do the 45, couldn't you, as well? It depends. There's loads of different ones, different ways to do it. You could do, well, this one's 45, which is the same as this whole thing, and then you just minus the 20. I guess that's easier, actually. But yeah, there's normally different ways to do circle theorems questions. The one that I thought was the pink one, basically, the pink kind of concept. I guess that might be a bit longer, though, because I'm now going to work out the angle in triangles. So I did like ADB is 180. It just depends which one you kind of see first, doesn't it? In the question on the day is 180 minus the 20 plus 135, which is obviously because of triangle, and then that just gave me 25, and then I was like, well, that's the same as what was it called, SBA, because of alternate segment theorem. SBA is also 25, and then write down obviously alternate segment theorem. But yeah, whichever way you did it, you might have done it the other route with the green colors. That's also fine. Exactly, that's what I'm saying. 45 minus 20 might be easier. It just depends what you saw first. So either way, it's effectively quadratic, a cyclic quadrilateral, and then alternate segment theorem. It just depends on also on other people's understandings of how to use alternate segment theorem, because you've got two triangles, I feel like the second triangle might not be as obvious. Some people might not know how that relates, if that makes sense, and they might just focus on this first triangle. So yeah, either way, you'll get 25. So it is 4 marks, but I'm pretty sure it was, you obviously get marks for your reasons as well. So let me just check the mark scheme. I'm pretty sure it was 2 and 2. Let's see. So you get a mark for obviously sharing out the ratio. That's 1 mark. You get a mark for, let's see, to find, I did this one. They've given like multiple options, that's the thing. So you might have done a mark for 45 degrees for your second mark, but as long as you've got like 2 lines of working out, basically. Then you get 2 marks at the end. One is obviously for stating that you've got 25 as your answer, and the other mark is for, you also have to give both, they've said both reasons, so you have to specify the cyclic quadrilateral and the alternate segment theorem, both of those. If you only give one reason, you'll only get 1 mark, so like 3 out of 4, if that makes sense. Yeah, I try to measure it based on, you know, if you're not really sure what to do, sometimes I measure it based on the number of marks, because it is kind of a clue as to their marking, because they're looking out for this line and then they're looking out for another line and so on. Because it's 4 marks, I feel like it is misleading though, because it wasn't a long question. 4 marks kind of makes you think it's a bit of a longer question, because what it was obviously normally you always get 1 mark for the answer, so just discount that immediately from your working. So then there was only 3 marks for working, but even then, one of them was for the reasons. So actually, it was only 2 marks for working, which is not a huge amount of working, is it? So yeah, you can kind of think, well, there's probably only maybe 2 steps of working that I need to write down, for example. So obviously the ratio, and then either if you did the triangle like me, or whether you just went directly and did 45 minus 20, that would be your second mark. And then obviously your third mark is for your reasons. You have to put both, and then your 4th mark is the answer. So yeah, with circle theorems, just double check, have they told me to give reasons? Because then the number of marks includes the reasons, which means there's fewer steps than what you might initially think. Question 15, here we go. Now this is what you were saying earlier. Now, do you see how we're kind of beyond halfway? And also it's no longer a right angle triangle. So I'm already in my head thinking some form of sine rule or cosine rule, or if it's the area one, do you know what I mean? That's kind of what I'm looking at here. So we've got triangle ABC. Part A, find the length of BC. So either sine rule, cosine rule, you just have to figure out which one it is. In this case, it's kind of, it normally only fits into one or the two of those rules, right? It normally only fits into one of the two. So you just have to figure out which. In this case, to me, it's kind of screaming out that it's cosine, because cosine rule is, first of all, 3 sides, 1 angle, and obviously they've asked us to find another side, so that would make 3 sides, 1 angle, wouldn't it? But also, it's always the opposite side to the angle, and then you've been given the 2 sides between. So you see what I mean? Like the setup here is very much just cosine rule. Obviously, that's on your formula sheet, but I will write it down here. Yeah, you can't do sine rule because there's not enough angles. It just doesn't fit, does it? With sine rule, you have 2 sides, 2 angles. We have 2 sides, we don't have 2 angles, and they haven't asked us to find another angle, so it wouldn't make sense to use sine rule, yeah. So this one, because we're looking for a side, we can just sub it all in straight away. You can see that this is side A, B, C. If they don't label it correctly and you want to, you know, make sure you're subbing it in correctly, you can just scribble out, let's say you could scribble out this and label it to match the formula. That's also fine. But in this case, they have labeled it correctly, so that's good. 11 squared minus 2 times 8 times 11 times cos 72. Quite a nice one. There's 3 marks for just basically typing into a calculator, is literally all it is. Obviously, just make sure you type it in right. That's the only thing, isn't it? 8 squared plus 11 squared minus, I tend to open a bracket now, 2 times 8 times 11 times cos 72, close both of the brackets. Now, just be careful though that this is the squared version, isn't it? So don't forget that you do need to square root. I don't think you necessarily have to write down the squared version, but I'm just going to do it for some marks. Obviously, I'm not going to round it to 130 in my calculator. I'm just going to straight away put square root of my answer. Now that this is the final answer, I will round it. So it says 3 significant figures, which would be 11.4. So yeah, 3 marks, that's quite nice. As long as you can identify which one it is, then yeah, it's quite easy. Part B is then find the area of the triangle. So I'm just going to come back so you can still see it. Just check. Yeah, you can still see all of that, can't you? So this is obviously then trigonometric area of a triangle, which is also on your formula sheet. But I will write it here, half AB sine C. This is what I'm saying. Obviously now the angles are in the wrong place, so I mean, you obviously might be confident enough to just sub it in as it is, but you might prefer to go, right, let me just cross that out. That one is obviously C, and then so on. You might want to do that. That's absolutely fine. You can always annotate whatever you want to annotate. I think this one's fairly easy. It's obviously just the angle and then the 2 sides that surround it, isn't it? So it doesn't really matter which way round you put the sides either. Obviously, just don't use the 11. So that would be half 8 times 11 times sine. Just don't forget to use sine this time as well. That's the other thing, I guess. So get rid of all that. Times 8 times 11 times sine, not cosine this time, sine, 72. There we go. And now they've said round it, because that is just your answer, isn't it? So 41.8 to 3 significant figures. Another really nice 2 marks. That was a really nice one, that one, actually. Not really too complicated. Already forgot what I said. 41.8, wasn't it? Yeah, 41.8. Error marks, let's see. The thing is with this one, for example, for part B, I would imagine it's 1 mark for the working, 1 mark for your answer. So I don't think there's anything to carry over there, but we could look at part A, because that has a few steps, doesn't it? Let me have a look at the mark scheme. I feel like they were, obviously, if you made an error initially, they wouldn't give you the answer, because obviously it wouldn't be the right number, but they might give you a mark in the middle. So let's see, what was this? Question 15, right? Yeah, 15. Okay, so they've given you a mark. It says for start to method to find the length of BC. So for example, if you wrote this down, just starting the method basically. Then mark number 2 is for method to use correct order of operations, which is the 130 bit. So no, I don't think this one has enough marks in it to get marks even if you typed in the wrong numbers, if that makes sense. I don't think this one. Let's see what additional guidance they've given. Yeah, no, there's just not enough information. They have said they will allow anything between 11.4 to 11.5. Not that that's much of a range, but they have allowed it. And actually for the area, they have allowed a slightly bigger range. I don't really know why. 41.5 to 41.9. But yeah, no, there's no kind of marks for, like, error marks in this particular one because it's just not a long enough question. I think it would have to be a 4 or a 5 marker to get that type of thing, yeah. Question 16, iteration, obviously really key one for calculator questions, calculator papers. So use the iteration formula, xn plus 1 is equal to the cube root of 10 minus 2 multiplied by xn, to find the values of x1, x2, and x3. Now they obviously have to give you a starting value, so we're starting with 2. So I set this up into my calculator. You don't have to do it this way, but I think it's easier. Start by just typing in whatever their starting value is, so 2, and then it becomes your answer. Then get rid of that, and then type out the formula. So don't forget, it is a cube root, not just square root. We've got 10 minus, now I'd probably put it in brackets, 2 times, and then where it says x, that's where you put your answer, because that's going to input every time, isn't it? Yeah, normally it's only 3 times. I don't think they'd ask you more than 3 times. I've never seen anything where it's more than 3 times, to be honest. Maybe if it has a context. This one has no context to it, does it? It's not got an actual real life thing. So yeah, so to find x1, you just press equals. So what I'd probably do for my working is I'd probably write down the whole thing for x1 just so that they can see I knew what I was, what I was subbing in, like that, 2 times the original, and then write down what I got, which was, I think they only want like 3 decimal places, but I normally just write down all of them because I'm never really sure. So I just wrote down all of them. And then for x2, you just have to press equals again. See how it's changed? x2, I probably wouldn't bother writing down the equation a second time, so I'd probably just write down the answer that I got. And then obviously just do it once more. x3, there, x3, 1.8462. Yeah, you probably don't need this many decimals, but I just prefer to write them there. And then obviously you fill out this bit here. Now, in their official answer, they've given 3 decimal places. That's kind of what they've suggested. So you could then maybe write down here 3 decimal places. Yeah, like that. They have said they will accept accuracy of 2 decimal places or more. So let's say if you obviously don't just put 1.8, because obviously, like, that's all the same for all of them. You have to show that they are different values. So you need at least 2 decimal places. Yeah, I personally probably wouldn't round it. I think that's just me. I would personally not round it. I would just write everything that's on your calculator just to be safe. This is the suggested like answer. However, they've said anything from 2 decimal places or more. So if you put this, that would be fine. But obviously don't round it too much. If I was to round it, I might round it to like 4 or 5 decimal places. Like, I feel like we need quite a few decimal places, don't we, personally? That's just me. So yeah, I probably would just leave it as it is, just write all of the numbers. Might as well, because then you're safe if they've changed their mind on how to round it, haven't they? Sometimes, I guess, different mark schemes, even though it's Edexcel, sometimes they say you can round it, sometimes not. So it's a little bit hit or miss. So yeah, maybe just leave it as it is. That's what I would normally do, yeah. Okay. Let's see. So the values of x1, x2, and x3 are found in part A are estimates of the solution of an equation of the form x cubed plus ax plus b is equal to 0, where a and b are integers. Find the value of a and b. So we literally already need to do. Yeah, that's what I was saying. I'll write that there, and then if you round it here, they can see both. But as I said, don't round it to 1 decimal place, obviously. Make sure that you can see a clear distinction between each one. Like, they shouldn't be the exact same number. So as long as you don't round it too much. So what I would do is just take this and rearrange it. So what was it? Cube root of 10 minus 2x. So ignore the n's and all that. What I would just do, let me bring this up again, is you've got here, this is the formula basically, isn't it? 2x, and then just rearrange that to get back to what they've got. So we'd obviously cube both sides. It's only 1 mark, so you don't really have to write working out, but just kind of show you. Then I would obviously add the 2x, and then I would minus the 10, just so you get the right decimals. So do you see how x cubed is there? The 2, see how they put plus and plus? So the 2 is just positive, isn't it? But you see how they put plus b, which is obviously minus 10? Because they didn't account for the negative, you would have to account for the negative yourself. So if you just put 10, they won't accept that, because it is technically minus 10 because they didn't put a minus here. If they did put the negative, let's say they put minus here, you would just put 10, if that makes sense. So just double check what format, and that's not just for iteration, that's for all other questions when they say what is a and b, for example. Sometimes algebraic fractions do that as well, don't they? Yeah, if they've accounted for the negative, you don't need to account for it. If they haven't accounted for any negatives, you would need to write the negative. So yeah, just be careful. That's the only answers. They don't obviously give any other options. That is just it. 2 marks for both of them correct. Sorry, 1 mark for both of them correct. You don't get 2 marks, unfortunately. Question 17, histograms. Now, I know that you did get a histogram in paper 1, so I'm hoping that means you won't get it again. I feel like it's unlikely. It's quite a specific topic, isn't it? But I guess who knows? So some people took part in the first round of a competition. The histogram gives information about the scores of these people in the first round. So we don't know the total number of people. 20% of the people got a score high enough for them to qualify for the second round. We need to work out an estimate for the actual score needed to qualify for that second round. So what I would do here is I think you need to work out the total frequency to then find 20% of the total frequency, isn't it? So get your formula. Triangle frequency always goes at the top. It's the one with just one letter. That's how I remember. So I'm working out frequency, so I need to just multiply, obviously, the 2 axes. So for the first one we've got, just be careful of the scale as well, 0.8 times 5, which is 4. Then we've got, what's that, 1.6 times 10. Just be careful that obviously, you know, the width does tend to change as well. 16, and then that's 2.2 times another 10, isn't it? Yeah, 22. And finally we've got 1.2 times, now that one is 15, so that's 18. So then you can obviously add it up. Yeah, exactly, then times it obviously by 0.2, so I think that gave us 60. So 20% of 60, just times it by 0.2, which is 12. So we're saying the top 12 people, obviously the top people, not the bottom people. So after that, we then need to find out, well, yeah, obviously that's within this like bar, isn't it? It's within this bar here, somewhere between the 25 and 40, but how far? So this is frequency. I want to find out the class width, don't I? I know it's going to be, because I'm going to count backwards from 40, because obviously the top mark is 40, so count backwards from 40. So what I'm going to do to find the frequency is, obviously, if you look at this formula, well, the frequency to what I'm going to do to find the class width is obviously frequency divided by the frequency density, which I do know is this top one here, isn't it? So what was that? We said that was 1.2. So to find the class width for the 12 people is the frequency 12 divided by the class width 1.2, which is quite nice. That's just 10. So that's in terms of marks, isn't it? That's their score. However, it's not just like 10 out of 40, obviously, because it has to be the top 20%. So the last thing is you just have to remember it is 40 minus the 10. 40 minus the 10, so 30 marks. 30 out of 40 would give you, or would let you qualify for the second round. And that's 4 marks. 30, but yeah, as I said, you've already technically done histograms, so hopefully that won't come up again. Okay, so we've now got question 18. Here is a graph of y equals sine x for, as you can see, the range is x is between 0 and 360. Using this graph, find estimates of all 4 solutions of sine x is equal to 0.6, and then also just note that the range is also like wider, isn't it? They have gone not just this one, but technically another double, isn't it? Now, this is the same as the question we had. It was question like 4 or something with the graph, with the quadratic graph. This graph is y equals sine x. get my highlighter. The sine x and the sine x are the same. The only thing that has changed is what used to be y is now 0.6. So what that's telling me is I just need to find 0.6 on my graph. So it's positive, so that'd be here. And then obviously it's y, so just draw a straight line across. Do you see how that's what they mean by 4 solutions? Obviously there's 2 solutions that you can see from the graph that they've given you, but there's also technically another 2 solutions because it repeats itself. So what you can do, you've got 2 options here. You could try and just read it off there, or what I would do is I would just do sine inverse. It has said estimate, so I'm going to round the answer to like, I don't know, so what I would do is I do sine inverse 0.6 and it'll give me the exact number, but I do want an estimate, right? So let's say that I round that to 37. I'd probably just round that to 37. So this first one is obviously 37. Get my pen back. So my first solution is 37. Then, now you can obviously read it off if you want, but as you said, use the symmetry. It's a bit easier. Do you see how the symmetry is here? So 0 to 37 is obviously 37, but this one, this second one here, this is kind of almost breaching A-level, I feel like, this topic. Like you do this a lot in A-level. It makes a lot more sense then as well anyway. And this one is like back from 180 at the same amount. So do you see how that one you add 37 from 0, this one you minus 37 from 180, because as you said from the symmetry. So I'm just rounding it to 37. You might have got a different, they have got a slight range of answers, so I'll show you in a minute. But I would do for this one 180 minus 37. So that's 143. That would be my second solution. But as I said, there's then technically 2 more. So do you see how here it will still be, again, symmetrical, so it'll still be 37, but do you see how the starting point for this one is now 360? So you're going to do 360 plus 37 for the next one, for the third one. No, that's not accurate, but you know, kind of get the gist. So that'd be 360, that'd be 397. And then the last one, we extend our x-axis. You've got to obviously figure out what the coordinate is here. This is just another 180 on, so that's 540, isn't it? So then that one is 540, same as the 180 one, 540 minus the 37. So that distance is still 37, but it's going backwards, isn't it? So what's that? 503, 504, something like that. Yeah. So those are your 4. 2 that you can see and 2 that do technically carry on because their range is longer. Now, as I said, they do give you a fairly decent range because I obviously worked it out more or less exact using the calculator. If you did just read it off, they have allowed anything between 35 and 40. And then obviously you would then carry on those numbers, right? So then they've allowed 140 to 145, 395 to 400, and then for the last one, 500 to 505. So as long as you've got anything between those, you know, those ranges, then that's fine. But this is kind of, as I said, breaching on A-level. So yeah, you'll do a lot of this kind of thing in A-level. Then obviously we've got some graph transformations. So the graph of y equals sine x is reflected in the x-axis. Write down the equation of the reflected graph. So when it's reflected in the x-axis, it's only affecting the y coordinates, isn't it? So you'd put obviously y equals, and it would be, obviously reflection is a negative, but it's a negative on the outside, not next to the x, because if it's next to the x, it means it's affecting the x coordinates, which means it's a reflection in the y-axis. If it's on the outside, it's affecting the y coordinates, which is a reflection in the x-axis. It's kind of confusing, but yeah, as long as you've memorized your graph transformations, then you can kind of backtrack it and work it out from there. Obviously, you have to use the sine bit. When it's trig graph transformations, we don't use f of x anymore. We use the actual sin, cos, or tan. Now, there is another one, which is just like a normal graph transformation. So here's the graph of y equals f of x. On the grid, draw the graph of y equals f of x minus 2. So you just, again, have to just memorize it. You have to memorize what the graph transformation means. It is a translation, but more specifically in the x-axis. You don't have to write this down. I'm just kind of doing that show you my thought process. And then, but the x-axis is always something the wrong way round about it, isn't there? There's always something slightly wrong about it. So that means it's not minusing 2, it's not going to the left, it's actually adding 2. So we're going 2 to the right. Yeah, exactly. So just pick some of the kind of exact coordinates and just move them 2 across. Just double check the scale as well. So that would be here. That one would go to 0, wouldn't it? And then that one would go to 1. That's a halfway one, so I probably won't do that one. I'll probably just do this one, which is then 2 more. And then obviously this is straight line, so you can just get your ruler and draw it straight. Something like that, yeah. So it's only moved across by 2, nothing else has happened. It's just one transformation. Okay, question 19. A, B, and C are 3 spheres. The volume of sphere A is 125 centimeters cubed. The volume of sphere B is 27 centimeters cubed. The ratio of the radius of the sphere B to the radius of sphere C is 1 to 2. Work out the ratio of the surface area of sphere A to the surface area of sphere C. So there's quite a lot going on there. This is just like that surface area to volume ratio type thing. It's actually kind of easy once you know what to do with it. So what we want to do, oh, I guess you might write it differently to me, but they've chosen 125 and 27 deliberately because you see how they, obviously it's cubed, volume is cubed, isn't it, 3D, they are cube numbers, so they've chosen that deliberately. So what you can do is you can almost write a, if I get my pen, write a ratio A to B. The volume is obviously 125 to 27. Don't worry about what the fact that they're spheres. You don't need to, you don't need to use any formulas. It doesn't matter what type of shape it is. It could literally be any shape. We're just going to think of it really basically. So just imagine it's volume is 3D. Just think of it that way, 3D cubed. To get, let's say, the radius, and I don't mean literally the radius in centimeters, I mean just like the ratio of the radius. You would just cube root it because a radius, or in other contexts, like a side length, is just one dimensional, isn't it? So think of it that way. That's why they've chosen cube numbers. So the radius would be for A, 5, and for B, 3. Now, I'm not saying it's 5 centimeters. It's not literally 5 centimeters, obviously. It's going to be some kind of decimal. But the ratio is 5 to 3, isn't it? That's one dimensional. That's how I imagine it. So I square root, square, cube, depending on what I've got. Now, they have then given us the ratio of B to C, haven't they? For the same thing, for the radius. It's not that the radius is 1 or 2, it's just that that's the ratio, isn't it? So I can line that up here. Now, do you see how I've got an overlap of B, as in they both have B in them? So what I could do is scale them to make maybe like a 3-part ratio for the radius. So I would probably just multiply this one by 3. That's the lowest common multiple, isn't it? So do you see how I could write... Again, you might lay it out differently to me, but I'm just kind of showing you this. For the radius would be 5 to 3 to 6. To 6. And then to find, because they're not asking for the literal surface area, so again, I don't need a formula. They just want the ratio of the surface area. So then the surface area, think of area squared, 2-dimensional. I'm just going to square. Yeah, once you know what to do, it's fine. But I feel like if you've not seen it, or if you've not gone through it before, I would have no idea where to even begin. Just square all, well, you don't even need to square all of them because we don't technically need B anymore, do we? We just want A to C. So square the A, 25, square the C, 36. It doesn't simplify, so A to C, surface area, which is just 2-dimensional, squared, 25 to 36. Yeah, so yeah, with these ones you don't need to have any kind of formulas. If it is clear that they're talking about ratios and surface area, volume, side lengths or radiuses or something like that, you don't need to have any formulas. Because I have seen an example, I think I've seen one where it was like a chess piece. Now obviously we don't have a formula for the volume of a chess piece, so there's no way that you could have used like a formula because there isn't one. Well, at least not one that we would know. I think there was like vases. Again, you wouldn't have formulas for those. So it's not a formula situation. It's literally just imagine that they're cubes, if that's helpful. Just imagine that they're cubes. Do you know what I mean? If the volume is 125, then cube root it to get the side. Do you know what I mean? Like that's all I would do. Let's see. Or equivalent. Let me have a look at the mark scheme. what was this? Question 19. Yes, or equivalent. They have allowed if you put it 1 to 1.44. I don't know why you would do that, but if you did, they would allow that. But yeah, any equivalent of that, that's fine. No, 5 to 6 isn't the same ratio, no. This wouldn't simplify to 5 to 6. Yeah, it has to be the squared version because the 5 to 6 is only the radius, but they've not asked for the ratio of the radius. They've asked for the ratio of the surface area, so that's why I had to square it. Okay. Yeah, so but once you figure this out, like just some kind of square root, cube root, some kind of it depends. Obviously, every question that they do on this comes from a different angle. So just figure out what they've given you, and then figure out, do I need to do like a square root or a cube root? Do I need to just square it or cube it? Do you know what I mean? Like try and figure that out. But they will normally give you numbers, even with a calculator one, numbers where you can recognize they're either square numbers or they're cube numbers, and then you're like, I could easily square root or cube root that, for example. So yeah, definitely. Once you know what to do, it's actually okay. It's not actually that bad. Yeah. It might not always be cube root and then square it, because it just depends what the question is, right? But there's some version of that, isn't there? Some version of like cubing, squaring, cube rooting, square rooting, that any of those things, you just figure out which one is relevant for the particular question. Okay, so we've got 2 more questions. Question 20, we've got probability, which I think you had a really hard probability question in paper 1. But I don't think that's going to stop them from bringing it up again, to be honest. I feel like probability they could bring up, obviously in different formats, but I think I don't think that's going to stop them from bringing it up again. So here we've got that in a village, if it rains on one day, the probability that it will rain on the next day is 0.8. If it does not rain on one day, the probability that it will rain on the next day is 0.6. A weather forecaster says there is a 70% chance that it will rain in a village on Monday. Work out an estimate for the probability that it will rain in the village on Wednesday. So we've actually got Monday, Tuesday, and Wednesday. Yeah, I would personally use a tree diagram. Some people don't. Like, you don't have to. There's no kind of, they've not drawn it for you, but I personally would, just so that I can visualize it. That's my preference. So we need basically 3 branches, or at least that's how I would do it. So we've got Monday. For Monday, we're going to use this one here, right? So I'm going to say rain, 0.7. I'm just going to say not rain, right? NR, not rain, 0.3. And then I'll start using these other ones. So for this branch here, for Tuesday, if we followed the fact that it has rained on Monday, the probability it will rain again is the 0.8, isn't it? If it rains on one day, the probability that it will rain on the next day is 0.8. So therefore not rain is obviously the other version, which is 0.2. That has to add up to 1. And then down here for Tuesday, if it didn't rain on Monday, the chances of it raining on Tuesday is the other one, the 0.6. And then obviously make add up to 1, so 0.4 for not rain. And then we've got another one for Wednesday. So you kind of need, this is where it gets a bit messy. Rain on Wednesday. If it's rained on Tuesday, then yeah, 0.8 again, isn't it? Not rain would be the 0.2 again. Just quite a big tree, that's the only thing. Once you've got the tree, then it's okay. Then here, if it didn't rain the day before, then it's the 0.6 and the 0.4. And then 2 more. If it did rain on Tuesday, same again. 0.8, 0.2. And finally, if it didn't rain on Tuesday, it's 0.6, 0.4. So you've got this whole tree. I like to highlight it. I know you probably don't have highlighters in your exam, but if you can, try and visualize it, maybe you might want to use squiggly lines or something so you can identify which of the branches, if we go back to our question, satisfy the question. So it says, work out an estimate of the probability that it will rain on Wednesday. So which branches would lead us to it raining on Wednesday? Well, it could be rain all 3 days. It could be rain Monday, not on Tuesday, but it obviously has to rain on Wednesday, right? Then it could be not Monday, yes Tuesday, yes Wednesday. And then there's another one, not Monday, not Tuesday, but it still rains on Wednesday. So I now need to work out all 4 of those probabilities. When we're working between the branches of a probability tree, we always multiply. So for each of these options, I'm just going to do them separately, right? So for the yellow one, 0.7 times 0.8 times 0.8. For the blue one, 0.7 times 0.2 times 0.6. For the green, 0.3 times 0.6 times 0.8. And the last one, the pink one, 0.3 times 0.4 times 0.6. And then, because there's 4 different options, only one of these scenarios can happen, right? Because you can't do Monday, Tuesday, and Wednesday twice or 3 times. It's only going to happen once, isn't it? So it'll either be yellow or blue or green or pink. So when they say or, it's the or rule, which means add. So we're going to multiply all these and then add them. I don't know if you can highlight on the exam paper, because I don't know if you're allowed to bring highlighters with you anyway. So maybe one to ask your teacher. I'm not sure. I'm not sure if you can. Maybe ask your teacher. I feel like they would know for sure. They would give you a definite answer. I'm not 100% sure though. So, but that's just how I like to identify it. Obviously, I'm not going to be in the exam, so it's just easier when I do past papers to do it like that. So I'm probably just going to type it all in at once, to be honest. Let's see. Do we need to write down the individual probabilities? For a process to find a correct triple probability product. Well, yeah, I've done the process, haven't I? I've written down. Obviously, I would write this down below if it was on the actual day. Don't write outside the lines, obviously. I'm just trying to keep it on one page for you. Yeah, I don't know if we need the. Let's work out the individual probabilities and then just in case they want us to write them. I would have just probably typed it all in directly otherwise, but then there's, I guess, more chance of getting it wrong. If you type in one number wrong, then obviously the whole thing's wrong, isn't it? So the first one, 0.448. I can still see that. Yeah, just about. Let me see if I can move it over a bit. Oh yeah. Okay. The second one, unfortunately, I don't think any of them are the same, so you can't just, you know how sometimes they're the same, so you just in a different order, so you can just add them together straight away, but I think these are all different. So yeah, quite a big one, this one. What was it, 0.6? You can write the fraction down as well if you want, but the decimals aren't too bad, so that's why I'm doing the decimal. 0.084, don't forget the 0. 2 more. 0.3 times 0.6 times 0.8. 0.144. And lastly, 0.3 times 0.4 times 0.6. 0.072. And then obviously just add all of these together. So I'm just going to use my answer there for that one. Plus 0.144 plus 0.084 plus the last one, 0.448. Obviously you should have something less than 1, so 0.748, that seems fair, doesn't it? It's not anything bigger than 1, so yes, that's how I would leave my answer. It did come up in a fraction originally, didn't it? Hang on. Yeah, I think they would allow, I'd imagine they'd allow the fraction. I think with probability they don't really care. Yeah, they'll allow the fraction if you did put the fraction. They don't really care what format you put it in normally for probability. Hang on, let me just check. Yeah, that's fine. Yeah, so that's that one. It's just normal probability trees, but it's just really long because there was so much to calculate. That's the only thing, I guess, for the 4 marks. But I don't think it's too bad for the last question, that one. Well, the second to last question. This is now our last question. Which this one I didn't think was awful either. They haven't even given you that much space, really. They haven't even given you the whole page, have they? So, the time period t seconds of a simple pendulum of length L is given by the formula, which you can see t is currently the subject. Katie uses a simple pendulum in an experiment to find an estimate for the value of g. Just pay attention to that. Here are her results. So we have been told that L is 52.0, correct to 3 significant figures. And then we've been told that T is 1.45, correct to 3 significant figures. Work out the upper bound and the lower bound of the value of G. So do just double check, because obviously most of the time they ask you for the one that is the subject, don't they? But in this case, they've asked us for G. So the first thing, well, you don't really have to do it first, but one of the things we're going to have to do is rearrange this equation to get G as the subject. That's one of the things we're going to have to do. And then we can sub in, obviously, to find upper and lower bounds. So I might write it over here just so I've got more space. I think you can rearrange it in different ways, so that's fine. But what I did was I divided by 2 pi first. Obviously, just get that out of the way. And then square. So you can leave it in brackets, but I just literally squared. As long as you square everything, so 2 squared is obviously 4, and then you would have to square the pi as well, so like pi squared. Or you could just leave it in brackets squared if you really wanted to, that would be fine. And then you get L over G. Now, obviously we want G as a subject, so it's up to you however you want to rearrange this. I personally just like cross-multiplied, as in multiply by the denominators, just to get G out of the denominator. So you don't necessarily have to write it in this many steps, I'm just kind of showing you everything that I did. And then I would divide obviously by the T squared. So this is what I got as my formula. You might have it written slightly differently. As long as it is an equivalent, then it would be okay. Yeah, so if it's multiplication, also the same for adding. Adding and multiplying, you just keep them together. If I want the upper bound, I use both upper bounds. If I want the lower bound, I use both lower bounds. But if it's a divide or subtract, those two, then you have to mix them. So yeah, you just have to be really careful. Yeah, you said upper bound divided by lower bound for the upper bound. Yeah, just think about it logically. Just think, how do I get the biggest answer if I divide something? If I want the biggest outcome, I need to divide the biggest number, the numerator has to be the biggest number, by the denominator, which is the smallest number. That will give me the biggest outcome, won't it? And then obviously vice versa for the lower bound. If I want to get the smallest possible outcome, I will divide the smallest number by the biggest number. So yeah. So we've got this. That I think they only give you 1 mark for that, which I think is kind of harsh. But anyway, we've now got this. Now, for some reason, they have said, which I didn't even notice when I was doing it myself, they have said, even though it's calculated, to use pi as this number. Now, I originally worked it out using the pi button on my calculator, because I didn't even notice, I didn't read the question properly. They do accept it if you don't use pi, but I would, seeing they've said use pi, then as 3.142, use that. So for the upper bound of G, as you said, you're going to want the upper bound. Well, actually, no, we need to work out the lower bounds and upper bounds first, don't we? Getting too far ahead of myself here. So I feel like significant figures can be kind of harder to figure out the upper and lower bounds for, maybe. So sometimes if you find it hard to just do it in your head, sometimes I like to draw it out. You don't have to, but I'm just going to show you. So I think, okay, what's one significant figure below, as in, considering they're talking about the third one, right? So that one below would be 51.9, wouldn't it? And then one above would be 52.1, and therefore that's not the upper and lower bounds, right? The upper and lower bounds would be halfway. Because I feel like they've done this one deliberately. I feel like the second one's not so hard, but I feel like the first one, you could easily think it was 52.5 and 51.5, but that would be 2 significant figures, not 3. So yeah, just be really careful. They tend to, I feel like for upper and lower bounds, they want to kind of trick you up. So that'd be 51.95, and then this will be 52.05. And then the other one's not as difficult. The other one, you kind of just add the 5 and minus the 5 on the end, don't you? So for the other one, we've got what is it, 1.4 for the lower bound, 45, 1.455 for the upper bound. That one's not as difficult, I think. Okay, so now I can just sub them in, right? So we've obviously, don't forget the rest of your formula. So we have said pi squared, but they've said to use 3.142 squared, and then L. So for the upper bound of G, we said we need the biggest numerator. So the upper bound of L, which was 52.05, divided by the lower bound of T. However, it is still squared, so don't forget to square that one. I guess it's just kind of a hard formula, isn't it? I guess we don't really need the bracket there, do we? So 4 times 3 point... Oh, where's my bracket gone? No. Try again. There we go. 4 times 3.142. Don't forget to square it. Times 52.05 over 1.445, and then also don't forget to square that one. You get 984. I would just write down all of those decimals. I haven't really said how to round it, so I'm just going to write them all down. Might as well. Kind of same with the iteration, isn't it? So that one is 984.3677853, something like that. And then obviously the lower bound is then the opposite. So lower bound of G, 4 times 3.142 squared. Now you want the lower bound of L, 51.95, over the upper bound of T, 1.455, obviously squared as we said. So what I'd probably do here is I wouldn't go back and retype the whole thing. I mean, you can if you really want, but just change that to the 5. And then this one, 51.95. The rest is the same, isn't it? So we get 969.018164, something like that. And that's what I'd get. Now, they haven't really minded how you round it. Obviously, don't round it to less than 3 significant figures. So even if you rounded it to 984 and then 969, they're okay with that. Or any decimals beyond that. So obviously don't round it to like 1,000 because that would not show you any difference. Same with the iteration. You need to show that they are different numbers. So I mean, I'd probably just leave it as it is, to be honest. I would write those numbers as they are because it doesn't specify. But yeah, they don't mind how you round it as long as obviously you've got the first 3 digits before the decimal place, as they are. So that one's 4 marks, which I feel like should be 5, but anyway. Yeah, it was a little bit harder because of that rearranging at the start, I think. But yeah, otherwise that is the whole paper. I don't know if you can see the 4 marks there. There you go, 80 marks. That is the whole paper. As I said, tomorrow I do have a video on calculator tricks coming out. So a few of the things that we've done in today's paper, you'll see, not a live, just as a normal video uploading tomorrow morning at 8 o'clock. So you can watch that when it suits you. I will still be doing lives during half term, obviously, as well. So we will just carry on with the paper 2s and paper 3s. What else is there? I'm currently writing a predicted paper for paper 2. Obviously, it's quite vague because there's just so many topics that could come up. So yeah, it's not obviously for only using that as your revision. Try and revise as much as you can, as much of the content. I know a lot of people said for paper 1 that nothing came up that they revised, but then you still have to know the whole syllabus, right? I know it's quite hard to, but yeah, paper 2 is quite a wide open one. You just don't know what's going to come up. It could literally be anything. So definitely try not to narrow down your revision too much because that is quite risky, isn't it? As some people saw in paper 1. But otherwise, if you want to look at any of the topics that, if I've already done videos on them, any of the topics from this paper, I have listed them in the description. So you can look at those in maybe more detail. I've also listed in a load of other just general videos that I think might be helpful more generally, so you can have a look at those. Yeah, thanks. I'm glad that you found it helpful. The November papers, yeah, I do think they're a little bit different. I don't know why. I don't know if it's just me. I just feel like they do seem kind of harder, which is worse because this is normally a retake paper, isn't it? So it's quite mean of them. But yeah, luckily you guys are obviously doing the June paper. So hopefully, if you're okay with the November papers, then hopefully the June paper that you'll be doing will be okay as well. Yeah, I would say for going into A-level, it is a huge jump. I have looked at the GCSE, as you've mentioned, level 2 GCSE further maths. That is definitely like a middle ground. So yeah, that's probably quite good advice. You could have a look at the level 2 stuff for further maths. That would probably give you a bit of work if you wanted during the summer. But yeah, GCSE, well, I feel like most A levels are a jump, you know, science and all that kind of thing. Maths, it is a jump, but yeah, it does feel like a jump for sure. So yeah, if you want to do any preparation over the summer, obviously I don't focus on A level, so I don't have any content, but you've obviously recommended some really good people in the comments as well, so have a look at those. But as you said, further maths GCSE is probably quite a good one to have a look into. I think that's probably the best advice that you've given. Yeah. But obviously for right now, we just want to get through paper 2 and paper 3. So otherwise, if you have any questions, guys, just leave them in the comments. Feel free to reach out. And the next past paper will now be on Monday at 7 o'clock as well. I would assume that one would be, just there weren't some June papers, were there, because of COVID, so I don't think there was a June 2021. Yeah, there wasn't. We've just done November 2021, so yeah, I think we will be jumping to November 2020, which is technically the June paper, but obviously because it was COVID, they just moved it to November, so you might hear it be called November, sometimes it's called June. It's just the 2020 paper basically that we will be doing on Monday, and then we'll carry on June 2019, November 2019, so on from there. But yeah, otherwise guys, just make sure you do have your scientific calculator. If you don't, I have got one linked in the description, or just see if you can borrow one from, maybe if you've got siblings or cousins or just someone you can borrow one from, I'm sure that'd be fine as well. Or if the school might be selling them secondhand, so, you know, it doesn't really matter if you don't buy it brand new, but just make sure you do have your scientific calculator as well. So thanks for joining me in this live, guys, and I will see you on Monday then.